This transformation from standard form into slope-intercept form is really useful. When you graph from standard form, if you transform your equation into slope-intercept form, you can then check your graph. So you can check that your graph has the proper y-intercept and slope. Let us go ahead and transform this. 2x minus 4y equals 12. So this is in standard form. I want to transform it into slope-intercept. First, I will subtract ax. Don't need to memorize this. I just need to know that my goal is that my equation looks like this. So my x term needs to be on the right and y needs to be by itself. Subtract 2x from both sides. That gives me negative 4y equals negative 2x plus 12. Now I need to make y by itself by dividing by the coefficient negative 4. In general, I would definitely show my work this way, but for some reason on your notes page, I wrote it like this. I think maybe it was just a little bit more clear. So I would suggest using the fraction bar when you're doing this on paper, but in your notes I wrote divided by negative 4. Negative 4y divided by negative 4 just gives me y. That's what I want. I want y equals. And now here is the error-prone moment. I'm dividing each term by negative 4. What is negative 2x divided by negative 4? To find the slope, I'm just going to think about negative 2 divided by negative 4. 2 divided by 4, that fraction simplifies to 1/2. So negative 2 over negative 4 is 1/2, and that's my slope, x. 12 divided by negative 4 is minus 3. So here is my slope-intercept form, transformed form of 2x minus 4y equals 12. These are the same equation. I've just transformed the equation so that it's no longer in standard form. Now it is in slope-intercept form. Next example, transforming into standard form. Now you may transform this in a couple of different ways in a little bit different order. As long as you get the same final answer and you've justified your step, that's okay. I'm just going to go in this order. Add, subtract mx, make a positive, clear fractions. So first I want my x term on the left-hand side. To do that, I will subtract 3/8 x from both sides of my equation. That will put my terms in the proper order. X term, y term, c. Now I could combine the next two steps by clearing the fractions and making a positive all at once. I'm instead going to just make a positive first. The parentheses and the negative 1 is definitely the most common way to show your work here. I just really ran out of space on your notes. So I wrote it like this, but that is not really the most sophisticated way. Showing you're multiplying by negative 1 with parentheses is better. So negative 3/8 x times negative 1 is 3/8 x, plus y times negative y, that becomes minus y. And then equals negative 1/4 times negative 1, that now becomes positive 1/4. Last thing I need to do is clear the fractions. It's not in standard form if there are any fractions. I'm not going to rewrite the common denominator here because I can do this in my head. 1/4 is 2/8. I'm going to multiply both the left and the right-hand side by 8. But again, on your notes page, I ran out of room, so instead of showing the very sophisticated parentheses multiplication, I just wrote times 8. 3/8 x times 8 is 3x, minus 8 times y is minus 8y, equals 1/4 times 8, which is 2. This is standard form. A is positive, there are no fractions, and my terms are in the correct order. 3x minus 8y equals 2. Again, these equations represent the same line. They represent the same pattern. I've just transformed my slope-intercept equation into standard form.